Good morning, everyone. This is Lokesh. This is Lokesh, roll number 2495182122 from Aeronautical Engineering. The subject I'm gonna say today is maths with the course code AHS D08. AHS D08. The topic which I'm gonna explain today is in maths is homogeneous equations, which helps in understanding the role in earth science. Earth science. Let's get into the introduction. This presentation explores homogeneous equations and their significance in earth science, covering covering uh, the fundamentals, applications, and specific case studies. Let's get into the basics of homogeneous equations. The definition for the homogeneous equations are mathematical expressions that yield consistent results across various inputs in earth science. They help model the behaviors of natural systems under a uniform conditions. Let's know the importance in earth science. These equations are crucial for understanding geological formations. ఆడ పెట్టేసేయండి నేను తింటా ఆడ పెట్టేసేయండి నేను తింటా predicting natural disasters and assessing environmental changes. They provide a framework to model and analyze complex earth systems. So this homogeneous equations helps in earth modeling very much, which helps the scientists and the explorers to know more about the earth phenomena. So now let's know the examples in natural phenomena. Examples include the equations governing fluid dynamics in rivers, the stability of soil structures, the seismic wave propagation during earthquakes. These equations allow scientists to predict and analyze real world scenarios. As you can see in the given image, the natural phenomena of rivers and sand. So let's know the applications of homogeneous equations. Modeling geological processes. Homogeneous equations are used to create models that stimulate geological processes such as erosion, sediment transport, and tectonic movements, providing insights into Earth's dynamic systems. So as we can know the geological processes, homogeneous equations are used to create models. Let's now know about the climate change predictions. These equations enable accurate predictions related to climate also change by modeling atmospheric conditions and impacts, informing policy and research agendas aimed as sustainability. As we can see in the given picture, we can predict the climate change by homogeneous equations. Let's now know the resource management solutions. Homogeneous equations are management by allowing for optimization of extraction methods and conservation strategies. They help in modeling water resource distribution, assessing minerals deposits, and planning land use to ensure sustainability. Mathematical formulation also, there are many types. Let's now know the mathematical formulations. Formulating homogeneous equations. Formulating these equations involves identifying relevant variables and expressing natural phenomena mathematically. This includes understanding the relationships among different factors and constructing equations that accurately represent those connections. Those connections, where you can see in the correlated picture of formulating homogeneous equations of on Earth on geological locations. Solving techniques, various, sorry for the interruption of headings. Various techniques are employed homogeneous equations, including analytical methods, numerical simulations, and literative operations approaches. These techniques helps researchers. These techniques helps researchers can predict behavior, complex Earth systems. Let's now know the graphical representations. The graphical representations of solutions to homogeneous equations can illustrate trends and patterns in data. Visualizing these equations in graphical representation helps communicate findings and allows for easier comprehension of complex relationships in Earth systems. So by this we can understand that homogeneous equations helps in Earth equations a lot. So now let's get into the case studies. Earthquake models. Earthquake models utilize humorous equations to predict seismic activity, assesses risks, and understand wave propagation. These models inform building codes and disaster preparedness strategies, ultimately enhancing public safety. By this, we can predict the weather earlier, and we can move the we can evacuate the people in danger areas to safer places. Soil erosion analysis involves using homogeneous equation tremendously, and its impact on agriculture and environment sustainability. Understanding these processes enables better land management practices to mitigate erosion risk. Mitigate erosion risk, as we can see in the given picture of water flow stimulation water flows stimulation apply homogeneous equations to model hydraulic systems, gauge flood risks, and manage water resources effectively. These models play a crucial role in environmental planning and disaster response in activities. By this, homogeneous equations helps in various points, and by knowing వస్తున్నా నేనే by knowing interactive things about uh, real world analytics for knowing the disasters prediction and weather predictions. Let's now get into the conclusions. Homogeneous equations are vital tools in earth science, providing insights into into comprehensions. They aid in everything from resource management to disaster prediction, thereby enhancing your understanding and ability to respond to environmental changes. Thank you. This is Lokesh Chaudhary signing off.